Good morning. Okay, that's better, I guess. I'm going to give a little bit of news. Mostly I'm just going to give you some thoughts on things. Some might be a little bit controversial. I apologize in advance if they are. I like to be interrupted with questions. So if you have a question, feel free to ask it. The only dumb question is the one you don't ask. And to show mercy to whoever's holding the question microphone, I will repeat the question if you happen to ask a question. Okay, so with that, so not too much news since the Plone conference in Boston. Right before that conference, we released ZODB 5. And mostly we've been sort of solidifying that over the last couple of years. And Plone 5 now uses ZODB 5, so yay. The biggest new thing since then is NewtDB, which I'll talk about shortly. I haven't done any more work. You know, at the Boston conference, I presented some initial results from a prototype Rust replacement for the Zio server that was orders of magnitude faster. At the conference, I asked who thought performance of ZODB or Zio was an issue, and nobody raised their hand. Who thinks performance of Zio is an issue? See, it's the same thing. So probably not a lot more work on that Rust server until that changes. And then ZODB hasn't been my day job for about a year and probably won't be in the immediate future, unfortunately. I think there's a little bit of an opportunity with scientific data. About a year ago, I did a prototype at PyCon of storing pandas data sets in ZODB using blobs. A really interesting feature or aspect of blobs was that they are effectively database managed files. And a lot of scientific data ends up getting saved in files. And so there's an opportunity to store that data in ZODB via blobs. So there's a package that stores pandas data sets in ZODB via the feather format. And I've done some experiments related to a previous employer of storing NumPy data files in ZODB. And I think there's some interesting opportunities if you're into that. So NewtDB is the biggest thing since the last conference. There's a link to the site. It was an experiment in alternate branding. I consider it largely a failed experiment in the sense that I usually ended up having to explain that it sort of builds on ZODB. But it's actually basically a fairly thin wrapper around ZODB and rel storage. And what it does is it replicates the object data to a Postgres JSON-B column. The replication is intentionally lossy to make the data easier to work with. And it allows you to index and search your data with Postgres as opposed to using catalogs or using an external indexer like Solr or Elasticsearch. And it also makes the data available to non-Python, non-ZODB applications. There's this little app that I like to demo this with. Let me see if I can get my mouse over there. A sort of pet project of mine is something called two-tier Kanban. I think this is a better way to do Agile. We did this at Zope Corporation for a while, and it worked really well. This is an app that implements that. The basic idea is that you have, so in classic Kanban, you have a board full of tasks, and the problem with that is that for development, or it works really well for support organizations, but for development organizations, you tend to work on projects or features that provide sort of units of value, and those units of value are made up of tasks. And so this basically allows you to represent both on the same board. For example, if I'm ready to work on a feature, which I normally wouldn't be unless the previous feature was done, I can pull it onto the board, and then it basically expands into a nested board of the tasks necessary to complete that feature. The main thing I want to show you today, though, is that there's this thing called the bag, which is essentially an archive. You know, when you finish a feature, you put it in the bag, or if you decide not to finish a feature, you bag it. You can drag features to the bag, and then you can open the bag and search it. And find the previous features that satisfy the search criteria. And this search is actually being done with the Postgres text index. And so this is using Newt, and it makes it fairly easy to do that. One of the things I like about using rel storage, because I'm really lazy, is that it lets me use a cloud database provider like Amazon RDS. And so it makes deploying really easy, because basically all my processes are stateless, and I let Amazon or Google or whoever do the work of actually maintaining the precious data for me. But anyway, so this was a search that was actually done with Postgres. Let's look at how you might do that in Python with Newt, and how you do the equivalent query in Postgres directly. So, a slightly simplified version of this search in Python. If you have a Newt connection, a Newt connection is a thin wrapper around a regular ZODB connection. You can also do something basically the same thing with a regular ZODB connection. But the simplest case is there's a where method. You give it the part of the query that actually specifies your criteria, and you actually get back a set of objects. And here we're using the full text search syntax. Something kind of interesting to note here is that we're searching against a stored procedure. So there's a stored procedure called extract text that takes a class name and the state. The state is actually JSON data in the Postgres type of JSONB. And this actually is very similar to what we typically do in a catalog. In a catalog in Plone, for example, you typically index methods on objects that have responsibility for grabbing the pieces that should be included in a text search and glomming them together. And it's basically the same thing, but instead of using a Python method, we're using a Postgres stored procedure, which in theory can be written in Python. I've never actually done that myself. The full query to get something out of the bag is mildly interesting. It's a little bit more involved, because we only want to find tasks that belong to that Kanban board. In the app, you can actually have multiple Kanban boards per team, and in fact, you can have sort of multiple teams. So the idea is that you can have multiple sites identified by the domain, and then within a site, you have multiple boards corresponding to multiple teams, et cetera. So we want to search for only archived items. We only want to search for items that belong to this particular board. And then, of course, we want to look for the text. So the first query there, each object, and this is just purely a function of this application, has a list of history list. So as you move things around, it records history. And we want the last item in the list to have an archive let's see, we want the last item in the list to have an archive property that's true. We also want the object ID to be 58 in this example, and then we want to do the text search. To see the simplified search in Postgres using the PSQL Postgres interpreter, here I'm just doing the text search alone, and you can get an idea of what the actual JSON data looks like. And again, it's a little bit simpler than what we store in pickles for various reasons, but it's pretty straightforward. We actually have the persistent reference in a couple of forms, and we store the so we have persistent references. We actually have them in two forms. One in a fuller form that ZODB would store, and then a shortened form that makes querying easy, which we leveraged before. So when we did the query, we asked whether the board's ID was 58. So that gives you an idea of how that would work. So the major benefits of indexing in Postgres versus using a catalog is it's usually faster. It's usually a lot faster. You also have a much smaller database. On a project that I was working on when I built this, something like 90% of the data in the database was catalog data. And of course, indexing and searching in Postgres is well documented. The advantage of this, perhaps, versus using something like Solr or Elasticsearch is that you have, by using Postgres, you have one fewer service to manage. So the dark side is that you have to be good with SQL or be willing to get good with SQL because you're sort of moving the complexity around a bit. There's a part of Newt called a QBE for Query by Example that helps you build Postgres indexes and construct Postgres SQL for common cases. You may need to, probably would need to write stored procedures. Again, this is a bit similar to writing methods that you hand to a catalog. You also can't index data from multiple records. Postgres doesn't prevent you from doing this, but if you do, your indexes will become corrupt. And then you'll ask a question on the Postgres mailing list, and people will tell you what an idiot you are. And so that it really limits the ability to index hierarchies. Postgres and probably most other modern relational databases support hierarchical queries. It's part of the SQL standard. It's definitely a thing. It's definitely doable. It's pretty fast, but it's not something it's a fairly advanced use of SQL. And you're limited to the degree that you can index things because you can index child and parent references, but you can't do something like we typically do in a catalog with the path index unless you actually store the paths in the content. Another interesting thing about Newt that you don't actually need to use Newt to leverage if you use rel storage to Postgres is what I call the follow API. And basically, again, regardless of whether you're using Newt or not, you can use this to be notified of changes to your database. You could use it, for example, to replicate to another database, to replicate to Solr or Elasticsearch or what have you. But it doesn't require that you use Newt, but it does require Postgres. So one way that this particular application uses this is that it uses this to provide a real-time UI. So this is a Kanban board. What we want is that when somebody makes a change to the board, that everybody sees that change in real time. To see an example of that, I need to arrange windows just so. So let's see if I can get that right. Okay, so here's a board, and I have a backlog down here. And I'm going to add an item to the backlog. I have some changes all in the oven, so I've taken them out. And so I have a site. This is typical ZODB sorts of things. So I've gotten a site. I've got a board from the site. I've added a feature, and I'm about to commit a transaction. Keep your eye on the lower right-hand or lower left-hand part of the board. And I got an error. Oh, darn. Okay, let's try that again. So much for having it in the oven. Probably because I move things around. Oops. And trying to type sideways is hard. Let's try that again. Yay. So Newt, this is something actually I've wanted to add to ZODB for some time. It becomes it turns out that the way you'd have to do it for something based on rel storage and something not based on rel storage is different, which is what's kept us from doing it sooner. But anyway, this is something that we can do with Newt and leveraging the follow API. So anyway, oh, I've lost my, just that. Okay, so I will take a quick fly through the logic. If you're interested, you can interrupt me or ask questions. Oops, that's not what I want. Oh, darn it. Oh no, that's going to be problematic. Oh. Okay. Let's try that again. So, sort of at a high level, this is if you use paste deploy to set up a whiskey pipeline, you end up defining a runner function that gets an app and some other information. Or actually, this is for a server. We're using gevent here. I'll say more about that in a moment. But here we're creating a function that creates a greenlet that simply iterates through database updates. And it gets object IDs. And below we keep, let's see, where is that? Here we have a default dict of polar. So basically, when a client connects to the app and asks for updates, we get the object ID of the object it's interested in updates for, and we save a list of clients that want updates about that object. And so then, when we get an update for a particular object ID, we then grab the polars for that object ID, and we set the event, which then wakes them up and lets them go ahead and actually get data. I'm going to go through this pretty quickly. If you don't follow it, don't feel bad. Ask me about it later if you're interested, or look more closely. The actual updates come from a function down here. It might be nice if there was a sort of a packaged up way to do this that made this simpler. But basically, we start, well, first of all, we do a query to get the last transaction ID for the database. And then we prepare an SQL query to get any updates since the last transaction. And then there's a Newt API to basically be notified of any sort of changes. When anything's changed, we get updates, and then we iterate through those updates, yielding the OID, which then is what we get up here, way up there. It would have been nice if I put those together. Where is that? Yeah, up there. And then what we also do is we create a whiskey application that that as requests come in, we see if they end with long poll. If they do, we look for some request parameters that give us a generation and an object ID. We create an event. We add it to the polars. We get the current generation for that object ID. And then if the current generation is less than or equal to the client generation, should be equal to, then we just sleep for 5 minutes. Otherwise, we remove the event, and then we enter the app as usual, which then gets the updates. I'll say more about the update process a little bit later. So speaking of async, so bear with me a second. That's not the one I wanted. Okay, I give up. at the Plone conference in 2016, some of us had some discussions about async and ZUDB, and there have been a bunch of questions on the mailing list about can ZUDB be used with asynchronous APIs? And the short answer is no. And the reason is that ZUDB really wants to be as transparent as possible. And when you do an expression like foo.bar, that could actually cause foo to be loaded from the database. And so it may or it may not. And if it does, then you don't really want to use this in an asynchronous context because you'll block other asynchronous activity. So maybe we could use something like await, like maybe we could await foo.bar, but that's kind of gross. And what about if we had foo.bar.baz? Conceivably, we could await that. I mean, I could imagine how you could have foo.bar return something that was not only a coroutine, but somehow if you did a get attr on it, it would return yet another coroutine. So I kind of have a fundamental problem with this kind of API. If you have a coroutine, then in order to get something from it, you need to await it. If you call that coroutine from some other function, then that function either has to call a specialized API to wait for the result, which kind of defeats the purpose unless you're at the very top, or that function also has to be a coroutine. So coroutines are kind of infectious in that everything that calls them typically up until pretty much the top of your application also needs to be a coroutine. So you've heard the expression turtles all the way down. Here we've got awaits all the way up. And because you don't know that the API you're calling is necessarily a coroutine or might be a coroutine in the future because it decides to call one in the future, there are some cases where you just sort of say, well, I'm going to treat everything as a coroutine. That's what Curio does, or at least did the last time I looked at it. It may have changed since then. And is this really the code we want to write? And for myself, I would say no. And an interesting thing, Guido gave a talk a few years ago at PyCon when he was talking about his design for async I/O. And he made a really, I thought, good criticism of gEvent, which is that with gEvent, how many people here have heard of gEvent? Okay, I'll say more about it in a bit. But gEvent is an asynchronous API. Well, it's an asynchronous library that avoids an asynchronous API. So you get to write imperative code. And it does cooperative multitasking, but you don't always know when it is doing that. So if you use it in sort of the lightweight way, then you kind of know, okay, I'm making a network call, so I'm gonna probably yield control here. But people who like to use gEvent like to use something called monkey patching that basically monkey patches anything that could block with gEvent in such a way that it could yield control. And you get to a point where you don't necessarily know when you're going to give up control. And one of the advantages, especially espoused by the Twisted community for async APIs, was that you didn't have to deal with threads, which are hard to get right, and instead you simply know that when you get a callback call, that that callback, if that doesn't make any other callbacks, is not going to be interrupted. Well, with gEvent, and particularly with as time goes by and people monkey patch more and more, you get to a point where you're kind of back in threaded programming land, where even though there aren't threads, you still have the possibility of other code being interleaved with yours and maybe messing up shared state. And I thought that was a pretty good argument against gEvent and a pretty good argument for async I/O and then what later turned out to be await. And the problem with that argument is that the same thing ends up happening with a more explicit asynchronous API, because as you use async for more and more, because In an async API, you're really not allowed to block. So you really have to find a way to yield control anytime you would block. And leaving aside the fact that if there's any computation involved, you can't avoid blocking, you end up with asynchronous processing happening everywhere. Has anybody here ever used IndexedDB on a browser? It's I'm going to point you at the code for that Valuenator project, the two-tier Kanban project, and one of the features it has is that the demo version doesn't require a server. It stores all of the task state locally in an IndexedDB, and you should look at that code. It's kind of a hoot. Anyway, so I think whether you're dealing with asynchronous or a purely asynchronous API like Await or a more traditional API like gEvent, you don't really avoid having to deal with interleave code. And gEvent just sort of accepts that and actually provides a lot of the same primitives for greenlets, which are the non-thread lightweight mechanism that it uses that you end up with in threaded programming. So I think there's a good alternative for asynchronous APIs that does work with ZODB, which is gEvent, and I've sort of come full circle on it. I've always liked it. I've used it for many years, and I've sort of come to realize that it's better than the alternative, in my opinion. And you know, I wouldn't fault you if you disagreed with me in any way. So. But it sort of retains the imperative programming model while still giving you the advantage of an async library for those cases where you might need one. It works well with ZODB. Lets you mix and match greenlets and threads. You can have greenlets, which are kind of like threads. You can also have thread pools if you need to. And it's maintained by Jason Madden, who really spends more time than I do maintaining ZODB. Which isn't to say you shouldn't use Guillotina. You know, maybe Await doesn't bother you. I went to a Guillotina presentation in North Carolina a few weeks ago, and there was most of the presentation was actually on Async.io, but the only Guillotina code that was shown didn't actually have any awaits in it because it basically just set up metadata for some content. So maybe you can even avoid that, depending on how into Guillotina you are. Maybe you don't care about transparent persistence, and maybe you only use the REST API. I mean, Guillotina sounds like provides great performance, and is probably a great tool. But I don't personally want to program that way, and ZODB will never be able to support that style of programming. So when do we need async? Traditional ZOAP programs, which to some degree is to say Web 1 programs, were characterized by typically being CPU bound. Certainly the applications we built at ZOAP Corporation were like this. And they avoided waiting. The way that we got to be CPU bound generally was by avoiding waiting for ZODB by making effective use of cache. And actually doing that is interesting in and of itself, and I'll say a little bit more about it. And by the way, speaking of ZODB cache, for a long time there was a notion that ZO client caches were unreliable, and that notion was true. And then many years ago at ZOAP Corporation, we realized that we really needed them to be robust, so we made them that way, and they have been like that for quite a while. So if you are CPU bound, you really should use a thread pool size of 1 and then scale by using processes. But some applications aren't CPU bound. If you ultimately if you're making network calls, you might be calling web services, which was I think the use case that drove Guillotina. You might be calling slow databases. We had customers in the past who were calling Oracle and spent a lot of time waiting for it, so use lots and lots of threads to mitigate that. Conceivably, even if you were calling a slow file system, although Python hasn't until maybe recently provided good asynchronous file APIs. And fortunately, we have SSDs today, but several years ago, I was fighting the fact that a disk seek on a large, meaning hundreds of gigabyte database could take several milliseconds and kind of kill us. But fortunately, today we have SSDs. Or you might be implementing a real-time UI using WebSockets or long polling, as I was just sort of flying through. So for these applications, you probably need an async framework. You might be able to get away with a bigger thread pool, but ZODB has a problem in this situation, which is that ZODB connections are kind of expensive because each one has its own object cache. The object cache is awesome, but if you make a lot of use of it, then having multiple connections can be a big problem. So then you're faced with maybe needing to reduce the cache size, and for some applications that works fine. But recently I proposed, meaning I created some issues on the ZODB issue tracker, for implementing shared state between connections. In the past, we've talked about maybe being able to share objects between connections, but that turns out not to really be practical for various reasons. But I think sharing object state, which is what you mostly care about between connections, is quite feasible and probably would be a great idea. And some low-hanging fruit include instance dictionaries. Most ZODB objects are just relatively regular Python instances, and that to the extent that their state is captured in their instance dictionaries, it would be very easy to share those instance dictionaries across connections with copy on write semantics, so that if all you did was read, you'd just be sharing the data, and then if you wrote, then you'd do a copy on write. And you could do something similar with B-tree buckets, which if you are using catalogs, take up a lot of space. So this would be a very good sprint topic if anybody would be interested in a project. Speaking of immutable, or on the previous slide, I mentioned that in order to make this work, you would need the state that you're sharing to only contain persistent objects, which means really references to persistent objects, or immutable state, or immutable objects. And so for several years now, I've typically used tuples instead of lists when I want a sub-object that's a sequence, just so that I can use an immutable object. I realized the other day you could use frozen sets in a similar fashion. It'd be interesting to use frozen dictionaries. There's actually a package on PyPy for that I haven't tried. Immutable data is very fashionable right now, so if you worked with this, the cool kids would respect you. Speaking of the cache, the cache is, my main goal with ZODB was to make it an object-oriented database that provided very transparent persistence. But there are a number of sort of characteristics that kind of fell out of the implementation, partly driven by that are really kind of interesting in their own right. And one is the ZODB cache. We sort of take it for granted, but the ZODB cache is a partial, transactionally consistent database replica. And so you don't have to worry about cache invalidation. The transaction system does that for you. We actually pay a price on writes for that, but the win that we get on caching is pretty substantial. There's this famous saying, the two hardest problems in computer science are naming things, cache invalidation, and off-by-one errors. But to use the cache effect, that was a joke, by the way. To use it effectively, though, you want to try, if you can, to get your working set to fit in memory, which means for some applications you want to use a lot of memory, or you should consider using a content-aware load balancer. I actually developed this several years ago, but for many years at Zope Corporation, my head was kind of down, solving the problems that we had, and I didn't really necessarily talk about some of the solutions very much, especially in this community. But with the content-aware load balancer, the basic idea is that the load balancer doesn't simply distribute load based on how busy machines are, but also on their suitability for a particular task. And with ZC resume LB, the idea was that individual app servers kept track of which kinds of requests they were good at, and when they connected to they would actually send that information to the load balancer, and so then the load balancer would sort of get a resume from each app server and then use that in making decisions about where to send requests. We were serving content for several hundred newspapers at the time, the content and the content management. We ended up distributing requests based on the site domain, and we started with about 50 application servers. We went down to 20 application servers, improved performance, improved cache warm-up times, because if the working set is really large, then that also means that when you restart something, you've got a lot more data to load into the cache. So there are other content-aware load balancers out there. If you have a scale problem, which you may not for an intranet, but for a public site, you might want to consider something like this because it can allow you to make much more effective use of the ZODB cache. So something I think about a lot is, how is ZODB relevant today? It's similar to the question that was asked, has been asked a couple of times this week so far, and I'm sure will be asked again, is, how can Plone be relevant? ZOP was built to solve Web 1 problems. How can we generate HTML on the server and send it to the client and manage that really effectively? And of course, today, a lot of the interesting application logic is on the clients. Servers tend to be a lot more boring. But I think there's, maybe I'm ignorant, it's quite possible, but I haven't seen a really good solution to how do you actually manage that data on the client. Given that if the server is the primary source of truth, how do you actually make sure that the data on the client and the data in the server are in sync? You can have a REST API that gets you data at a point in time, but how do you provide a consistent view and keep that view consistent, especially in a system where there are multiple users modifying the data? I don't really know what the answer is. I'm not even sure that question is asked enough. At least, I don't necessarily read in all of the right places, so maybe this question has been asked and answered, but, and if it has and feel free to tell me later. But I haven't seen a good solution to it. Something that we tried at Zope Corporation was kind of interesting, and again, I don't mean this to be the answer, but I think it was an interesting experiment and might be relevant to Plone. So basically, ZC generational sets model a collection of information as a tree of sets. And that tree basically gets a generation number associated with it, so that whenever you modify anything in the tree, the generation number changes. So at any point in time, if a client has data of a particular generation and the server has data of a later generation, then it's really easy, really easy for the server to compute essentially the diff that it needs to send to the client, and then the client gets just the data they need to update their state. Another thing that's sort of related to this is that when you see the state change, there are various ways that you can notify clients. In the demo that I gave, we actually didn't notify clients directly. We used the newt follow API so that the client would detect that there were changes. We did an application towards the end of Zope Corporation. We were we decided to experiment with a bunch of startup ideas, and one was a project called Reached, where you'd have a leader of a group who wanted to communicate to the group in real time for whatever reason, and it was a mobile app, and we needed to again provide real-time communication. And so for that, we actually used push notifications. And so when we updated a generational set, we would then send a push notification to the relevant clients, and then they would pull the changes, which they could do very efficiently because of generational sets. And it was pretty cool. I remember a few times we had to make some corrections for a leader, and we would update the data in ZDB and commit the transaction, and you could just look at your phone and see the screen update without actually doing anything, which is pretty cool. Similar to what we saw on the Kanban board. And it's in some ways a little similar to ZDB because like ZUDB, data are sort of automatically sent to the client. In this case, we were pushing notifications to the client, and then the client polls for the updates. In ZUDB's case, depending on what storage you're using, either notifications of individual invalidations are sent to the client, or in the case of rel storage, at the beginning of the transaction, the storage polls for changes. But the idea is that you knew that you had a consistent view of the state. Unlike ZUDB, it's not really lazy. So the client doesn't have to sort of contend with lazily loaded data. They get their state, and whatever state they have, they can access without blocking. It does require that you identify a state that's to be shared. So it has to be finite. In the Kanban application I showed you, the state isn't stored in durable storage on the browser, but in the reached application, we had potentially a lot more state, especially for users. So we actually did store state on the mobile devices. So you either have to have an inherently small amount of state, or you have to think of sort of chunks of state. But I can imagine, in a content management context, there's some sort of, again, context for what they're doing that's less than the entire site that perhaps you could do this with. In the Kanban board, it was it's a board. In the messaging app, it was the group that you were on. Again, not necessarily the answer, but I think it's an interesting approach that deserves a little bit of thinking about or playing with. Somewhat aside, it turns out it fits really well with the sort of React way of doing things. So React likes you to have a single state that you change centrally, and then the changes sort of flow down to the individual views. With generational sets, the client changes state by making a REST call to the server. The REST call, the code on the server updates the shared state. Those changes are then pushed back to the clients, and what the clients get are actually the sort of diff of their state that's changed. Clients then update the state centrally based on that synchronization information, and then the changes flow down to views. So it fits in pretty well with that sort of philosophy. The Valuator application is kind of interesting. Again, it's an application of something called two-tier Kanban. I've never actually found anybody else who's used two-tier Kanban. I didn't invent it. I happen to think that Scrum is dumb. I'm going to get a T-shirt that says that someday. You want one? Okay, so 2. Yeah, okay. But I think Kanban is pretty cool because Kanban's philosophy is to have a continuous flow of value. And so I think that's really good. And there's a lot around. There's actually some good practices in Scrum, I think. But I really like the Kanban philosophy of focusing on value. And at Zoe Corporation, we wanted to get to a point where we didn't really have team leads anymore, where we had self-organizing teams or self-organizing team, and we tried Scrum, and we then tried Kanban, but well, we didn't ever actually just try plain Kanban, because when I was researching Kanban, I encountered two-tier Kanban, which made a lot more sense for development. And so as I described earlier, in two-tier Kanban, you have a Kanban board of features that you're working on, units of value, and then where necessary, those get exploded out into the individual work necessary to get those features done. And the idea is that the team works on as few features as possible, the individuals work on as few tasks as possible, and that you organize the team around getting value done, getting value in front of customers. And that has a lot of really nice effects. It keeps the team focused. It also tends to avoid silos, because you eventually get to a point where the team is focusing on getting value, sort of over the goal line. And when they are, then team members are willing to do whatever it takes. A back-end developer is willing to work on the front end, or vice versa, or clean toilets, whatever it takes. So I think it's an important process. So I would love for people to try it out and to continue to, and this is an open source project, continue to evolve the tool. But it also is interesting because it demonstrates a lot of what I've talked about today. It's a new DB application that uses indexing and searching with Postgres. It provides a real-time UI based on generational sets. It does React state management, and it's also using an asynchronous framework that provides an asynchronous API, being G-Event. So I encourage you to take a look at it, and I would love people to try it out. Concluding, I'll be around for the sprint on Saturday. The ZODB issue tracker has most of the issues in there are actually enhancement ideas, and a lot of them are good sprint topics. So if you're interested in getting more involved in ZODB, that would be a great opportunity. I will be around this week, and I'm happy to answer ZODB questions. Most questions I tend to get are hard, so I often don't give answers, but I'm happy to give advice and talk about and even dig into some things. You haven't asked many questions, so I would encourage you to do so. And the last link there is the link to the slides if you'd like to look back. So any questions?
Cool. A great talk, thank you. How does Newt compare to just using, for example, SQL Alchemy or ORM? Because if you have to construct search queries manually, with SQL Alchemy, you can use the ORM to construct the search query. So, like, what's a good use case where SQL Alchemy, for example, is not suitable, or Newt is more suitable?
Well, I think the basic answer to that is ZODB versus SQL Alchemy. So ZODB provides, SQL Alchemy does a pretty decent job of automating a lot of the persistence. But I think ZODB goes a lot further, makes it more transparent, and then there are a bunch of other aspects of ZODB that are kind of interesting. I actually find that I worked on a project that used SQL Alchemy a couple years ago, and it wasn't the super best example of this because they had a very complex, it was a health company, and they had a very complex schema, and SQL Alchemy actually mostly got in the way. I actually like SQL quite a bit. But anyway, yeah, I think it's really a question of whether you use ZODB or an ORM. And then if you're using ZODB, then the question is, how do you search your data? And traditionally, over the years, people have tried to figure out the best way to do search in ZODB, and catalogs provide something that's kind of loosely SQL-like in the sense that you've got things that look like tables and indexes, and you search with kind of a query by example, which is kind of what SQL Alchemy does. If you've decided to use ZODB for a bunch of reasons beyond just object transparency, but mostly because of database transparency, then I think NewtDB provides some help with managing the search more effectively. Any other questions? Arguments are accepted as well, by the way. Okay, well, thank you very much.
Thank you very much for the presentation.